Hello explorers and welcome to another video. Today we are doing the Advent of Code puzzle. The Git repository is linked in the description below, and if you want to see all of my trials and tribulations, you can see the full recording as a member of this channel. So let's do this. Number 3, day 3. Let's click in. Rucksack reorganization. One elf has the important job of loading all the rucksacks in with the supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and also a few items now need to be rearranged. Each rucksack has 2 large compartments. All items are given a type meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item per rucksack. The elves have made a list of all the items currently in each rucksack, your puzzle input. But they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is A and A refer to different types of items. So lowercase a and uppercase a are different types of items. The list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, while the second half of the character represents the items in the second compartment. For example, you're supposed to have the following list of contents of 6 rucksacks. So what's the first and second part then? The first rucksack contains the items, and then we have a bunch of characters, which means that the first compartment contains the items, and that's those items, while the second compartment contains these items. The only item type that appears in both compartments are the lowercase p. Okay. The second rucksack compartments contains that and that, so they have split that into 2. And the only item type that appears in both compartments is the uppercase L. The third rucksack compartment contains 2 other letter cases, and the common item is P. The fourth rucksacks only share item V, and the fifth item T, and the sixth item S. To help prioritize the item rearrangement, every item type can be converted to a priority. Lowercase types A to Z have a priority 1 to 26, yes. And the uppercase item types have A to Z have 27 to 52. So that's the priorities. In the above example, the priority of each of item types that appears in both compartments of each rucksack is P, L, P, V, T, S. And the sum of these are 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those items? So there is a couple of things here. We need to have priorities handled. We need to figure out what is in the both parts of a rucksack, and the rucksack could be arbitrary length, so we need to split the string in 2. And we need to figure out what characters is in both of them, and then figure out what priority that character set has. So there is a bunch of things that we need to do here. So let's prepare this a bit. So now everything is prepared. I have copied the test data over and created a class here that is pretty much empty with only this reader logic. So let's see here. We have a line and it has a length. And what we want to do is take this length, divide it in half, and have the two halves of the string. So let's start there. String first, or maybe it's easier actually to do this as an array. So let's create an int array of chars, new int, like that. So now I have an item array with a bunch of chars, and then we can have a string here with alphabet, that starts with 0, for instance, because the 0th position is not interesting. All of those, and we put a 0 in the beginning here, which means that we have an alphabet with all the characters, and we start with the 0, so we will get the right score. So now we can, for string in line split with every character, then we can take chars and add the alphabet index of this string. And then we just need to increment I and start it at 0 here. So now we should have a char array, and for each of those we can take chars, arrays, copy of copy of range, chars 0 to chars length divided by 2. So int first, that's the first part, and then we have the second, and that should be from chars length. Let's do a system output here and see what we actually have. Like that. What do we actually start with here? We have a bunch of chars, and we have 2 chars array here. So 1, 2, these are 12 each, and they break at 18 and 8. So they are split in 2. And what we can see here is that they share what character with each other? 16. So that's the P, right? Yeah, P is shared, so that's 16. So so the very simplistic way of doing this is to have 2 for loops. K equals 0, K less than first length, K plus, there we go, and then have another loop in there that is J, and is the second. So if first k is equal to second k j, then score should be added with, let's say, first k. Doesn't really matter which. So if we run this, we get the score. Yeah, we get each of the scores. So I wonder if these scores were correct. Yeah, 16 seems right. So let's try to run this. 517. That was not it, right? No. So let's type the scores out again here. Let's see. So these are the scores that it reported. These are the scores that they say they have. So 16, 38, 42, 22, 20, 19. So why do I get a super high value set of integer scores? New set of integers. Hash it like that. So now I should be able to add scores, add this specific integer to the scores. And if we look down here, we should only have down here. We should only have the scores that is interesting. We got one score, 16. Yeah, that's correct. We only got one score, and that's 16. So, scores, summarize. Can you do that? Is there some kind of like that? So just get them. And we got them just once. And if we take the score and plus it there, we should have the right value here. So what I did here is I added them to a set, which means that I should have only the values that are unique. And then I added them to that set, and then I run a stream over that set and reduced it down. So reduce is a function where you can have a bunch of arrays in arrays and reduce them down to just arrays, or in this case we have a bunch of integers in an array and we reduce it down to one integer. And in this case it's a sum, because we have the first value, the second value. So this is, I don't remember if the first was, yeah, the first one was the accumulator, and then you have the actual sum. So you add them together and return that, and then you get a new sum for each of the iterations you go through. So let's see if we can then try this with the full set and see if that solves it and if it doesn't take endless time. So 7,746. Let's see if that is the correct value. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. So, part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For security, the elves have divided into groups of 3. Every elf carries a bag that identifies their group. For efficiency, within each group of the 3 elves, the badge is the only item type carried by 3 elves. That is, if a group's badge is item B, then all 3 elves will have the type B somewhere in their rucksack. And at most 2 of the elves will be carrying any other item type. Okay? The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges needs to be pulled out of the rucksack so the new authenticity sticker can be attached. Additionally, nobody wrote down which item type corresponds to each group of badges. The only way to tell which item type is the right one is to find the one item type that is common between all 3 elves in each group. Every set of 3 lines in the list corresponds to a single group, but each group has a different badge item. So the above example, the first group's rucksacks are these 3 lines, and the second group's rucksacks are these 3 lines. Okay. In each first group, the only item type that appears in all 3 rucksacks is R, and this must be their badges. In the second group, the badge item type is Z. Okay. Do we have Z in all 3? Yeah, we have Z in all 3 of them. Yeah. Priorities for these items must still be found to organize the sticker attachment efforts. Here they are 18R for the first group and 52Z for the second group. The priorities of these items must be found and organize the sticker. Okay. So for the second group, the sum of these is 70. What? Priorities for these items. The first group, the only item types appears in all 3 rucksacks are lowercase r. In the second group, their badges of item must be Z. Priorities for these items must still be found to organize the sticker attachment efforts. Here they are 18 and 52 for the second group. The sum is 70. Find the type that corresponds to the badges of each 3 elf group. What is the sum of the priorities of the item types? For safety, the elves are divided into 3 groups of 3. Every elf carries a badge that identifies their group. So every elf carries 1 rucksack then. Is my guess. So we should just split everything into 3 lines. Find which of 3 lines, which character is the only one contained in all 3 lines. Actually believe that we can do a B version of this now. So now we don't need to split the array up. We need more arrays. So this looks promising. They are working with hash sets instead. So why not do that? So we have an array list of hash sets. And then we will list index, add, and then our integer here. And we still need to do like that. So I have 3 lists. Lists and add 3 hash sets. And down here we will throw a bunch of it away and create 3 new hash sets. So then we should be able to take lists, get index 0, retain all lists, get 1. So I wonder what happens here. Let's see. So now we have lists that have 14, 16, and so on in them. And if we run the first one, we have 5 left, and run the second one, then we have 1 left, and that's 18. Interesting. And we said here that the only one that is common to them is 18. So I've learned something today. I learned about retain all. This was awesome. So what we want to do here is actually take lists, get 0, and then do the reduce again if there is 2 values. I don't know. B A plus B, like that, and then a get after this. So what will the score be then? 70. We did it. So let's see if we can run the large one and get the correct answer out of that. So that's 2,604. Let's put that in and see if that's correct. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. What? We solved it with a totally new technique. I actually learned something very interesting here. So what I did is that we created a bunch of sets. So we have unique values within different lists. So we have a set here, a list of set. We create 3 of them. So we have 3 in the list. And then we have a list index so we can actually keep track on which list we want to add things to. And then we didn't even use this char array here. We have an alphabet up here which has the right index for each character. So we look up that index and store that in the currently working list. And when we have done that for the whole string, we will increment the list index. And if it's less than 3, so we only have 1, for instance, of these lists so far, we will go on and do a second one until we have 3. So when we have 3 lists, so we can actually compare them, we will run this function here, which is the cool one, where you have a set and then you say retain all in that set that is not in this set. So we do an intersection. And then we do the same thing with the second one. And then we have a list here that only contains the things that are actually unique between the 2 lists. And then I will stream reduce that one, so I get 1 score and add that score up. Then if we need to do some cleanup here, create a new list and add the new hash sets to that, so we can do another round and set the list index to 0, and then we will read the next line. And when we've read all the lines, we will print out the score down here, and we will have our result. I was pleasantly surprised on how much I learned in this example. I hope that you found this fascinating. I hope that you liked this video. Did you solve this in a totally different way? Please leave a comment with the code down below or a link to your Git repository so I can look at it. If you liked this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, do that. And I really hope to see you in the next video.